Welcome to the 2023 question C1. This is the geological geometry question. So on the accompanying map located on the back of section A, so I've got it printed out here first. Okay, it has ground contours at 5-meter vertical intervals in a park pathway. Okay, so we're looking at park path here, and we've got 5-meter intervals between our ground contours. ABC is the center line of a pathway, and O is the center line of a circular curve which forms part of the pathway edge. So A, B, C, D, that's our pathway, and we've got our curved little element there, and center O. Pathway has the following specifications. A portion of the pathway from A to C is level at an altitude of 50. So A here is at 50. B is at 50, C is at 50. The portion from C to D rises uniformly to a level of 55 at D. So here at D we're 55. Okay, so flat portion, and then it tilts up towards D. Using side slopes as 1 is to 1.5 for cutting. So our cut, let's write this down here. Our cut ratio is 1 to 1.5, and 1 to 2 for embankment, so our fill ratio is 1 to 2. Complete the necessary earthworks to accommodate the pathway on the northern side. So we've got 5-meter vertical intervals. Okay, so our cut cone, our cut slope, we're going up in 5, right? So our ratio is, just draw this here, 1 is to 1.5, so 5 gives me 7.5. Okay, our fill cone, we're going 1 is to 2, so our fill cone then for traveling 5 is going to be 10. Alright, so that's what's going to help us to do our level part of the road to begin with, from A to C. So here we're at a level of 50. Okay, looking at the ground contours inside that, we've got 30, 35, up as far as here is going to be a fill. Okay, we're filling up the road so that, or the sides of the road so that it meets the path. Okay, so we're going to use our fill ratio over here. So we're going to be going up in 5-meter vertical intervals, so we need to go 10 each time. So I'm going to measure 10, 10, 10. So we're at 50, we're filling, so we're going to be going down to 45, 40, 35, 30. And using sliding set stairs because we want to be parallel to the edge of the road for a level road. Okay, so level road is at 50, so that's there. Then we're going to 45, then we're going to 40, 35, 30, and there's no other contours after that, so we can draw that in for now. Okay, this section of the road then still isn't complete, so we need to do a fill in this little portion. So if we're doing a cut into this section, that's our 7.5-meter vertical, or vertical, not vertical, 5-meter vertical intervals. We're traveling at 7.5. So we need to go 7.5. And just do another one. I don't think I'll need it, but I'll go another 7.5 there. So we're at a height of 50. Now we're cutting into the mountain, so we're traveling up in height. this line here will be at 55, and this will be at 60, and here we have our 65. Okay, so we're at 50, then up to 55, 60, and 65. I'm not sure we need all of those, but we'll put them in it for now anyway. Okay, at this point we are on the curved portion of the road, okay, and the height of the road is going from 65 still here to 55 and 50, so we're still going to be cutting into the mountain at this point until we get to here, okay, because that's our height of 50 on the roadside again. So I want to use my set square here as a point of measurement. Just go out and we're cutting, so it's going to be 7.5 again. 7.5. 7.5. Okay, so we've got our height of 50, 55, 60, 65, 65, 60, and then back down to our 55. Yeah, so let's draw that portion in. Okay, and they intersect. There's just a little bit of a crossover there. So I didn't need all of those points. I just needed probably as far as the 60 mark. And we want to join back to our corner to show the change in slopes there. All right. Now, next we are continuing on along our curve. Our heights there are at a lower height. So we're going to be doing from this 50 to this 50, we'll be doing a fill. Yeah, so we're back to our 10 intervals. Okay, so I can measure 10 off each of these. 10, 10, 10. I'm using O as my center. So I've got 50, 45, 40. I'm just looking there. I won't need any more intervals other than that. So going from our 50, this is our 45, 40, back to 45, and 50. So here's our next bit of the road, or bit of the fill. Okay, and then finally we're back to another portion. We're still on the curve, or over the road, so 50, 55, 60. So we're going to go back to our cut. So I'll use my distances there, my 7.5 that I've measured already for my cut. This is probably changeable things. So I've got 50, then up to 55, and 55, 60. Yeah. Let's see. That's all we're going to need. Yeah. Let's draw that in. All right. So now we're at this point in the road, okay, and where we've managed to reach as far as C. Okay. So let's see. In C, they told us that it's rising to 55. So we've gone up a height of 5 meters. So if this is our road, we're at C. It's sloping up. Okay, C is at 50, and we're traveling to D at 55. So the change in the height of the road has been 5. All right. So we are going to need a cone here. I'm just trying to sketch a cone out. So semicone, and that cone is going to be height of 5, and we need to work out what the radius of the cone is for that triangle. So it's traveling 5. So that's this triangle. Okay, traveling 5, and we are looking at the heights here. They're all at heights of going from 50 to 45. So we're going to be doing a fill here, because all these heights, 50, 55, they're all underneath my, they're all underneath here. I'm probably going to have to find another cone for this side. So we'll deal with our fill cone here first of all. So this is my fill cone. Okay, so 5, so that's going to be 10, radius 10. And we know that we put a fill cone on the hill, so on the high side. So let's first of all slice that square to get the correct edge. That's there, and that's there, just so I've got my seat. So my cone is going to be radius 10. Fill cone, and we're going to join that back tangentially. Okay, so that line, just use another color here, represents this line from the base of my cone to C. So that is at height of 50. That's going to be 50. Let's go to my 50 here, and we're going to be going up in 10-meter intervals. So 10, 10, 10, and even just put one below it just in case I need it. So we're at 50, 45, be there and there. There's no 40 actually, so I don't need that. And then we've got 50, 55, which I will need because I want to need to find where that joins back into the road. So sorry, 50, 55. Okay, join to my 50 mark, and then I have to find where it cuts into the road exactly. So that's there. And back to my 50, 55. That's where we'll join back into the road there. Okay, so we can see now there's 2 parts of the road I still have to do. So I need a cut cone for those. So let's do my little calculation here for a cut cone. Sketch again. Okay, I'm traveling from 50 to 55. Okay, so my cone that I'm going to have is going to be here. Alright, the height of that cone, it will have traveled 5. Okay, and the radius of that cone, let's work out that triangle. The radius, we're using our cut radius, our cut ratio, so that's going to be radius 7.5. Radius 7.5. Alright, and we know that the cut cone goes on the foot, right? So on the low side. So radius 7.5. And that cone is coming in here. and that line is drawing from top of the cone to the top there of our slope, so that's going to be at a height of 55. So from D tangential there, that's 55. So come on, it's 55. Just a mark I'll need there, and actually need it there as well. Okay, so now we are going 7.5 intervals again. It's our cut. And we'll go in the way as well. Right. Okay, so we're at 55 here. We're cutting in, so higher is going 60. Okay, then we're back down to 55 again, so there. Almost identical points. And then we're coming down to 50, so that's going to be a point there that we need to find to make sure they intersect. So flowing up. Okay, back to 55, and then we're down to 50 again, so that's where they're going to cross over. Alright, turn that back to the corner. Up on this side then, we haven't extended those far enough. So we're at 55, just here. So that's 55. That's my main line. 60 is above it. Do we have any 60? Yes. 60. 65. Okay. And then we also need to find a point in here at 50, which is there. So, okay. So we've got a range there of cuts and fills. And that completes our earthworks. Okay. Part B, on a separate diagram on the map, the elevation and plan of 3 supporting poles P, Q, and R are shown. Okay, so similar to what we're seeing here in the image. Okay, we've got a pole, and another support pole there at the back. Okay, so that's the elevation of those poles. The plan of a triangular canopy attached to those poles is also shown, so it's similar again. We've got a triangular canopy. Here's the plan view of those. Okay, draw the elevation of the canopy. So the height of all those will be contained on the elevation. So what we'll do, workspace, keep this to the side so we can see it. So I'm going to project up. They've already guided me there, so that's 1 point. Q, project up. So that's going to be one edge of our canopy. Okay. Or then we can't project that up, so we need to find another way of getting that. If I rotate, so this is a pole, if I rotate that around to this position, like that, when I'm looking at the elevation, I should be able to see the heights. So rotate pole R. Right, I'm also going to rotate the position of the canopy because I need that. Okay, so this gives me the true length of pole R, and then that is where our canopy is on R. So I can bring that across there. So here's my canopy. canopy found there. So elevation of the canopy found. Determine the strike and dip of the canopy. So my strike is a level line on this plane. Okay, it's a canopy, but we follow the plane or a laminate. So I'll do a level line. I'll bring that down, so along this edge of the canopy, which is here. Let's drop that down. That's my strike. Okay, and that's done. So now I want us to find the dip. So the dip, we want to see an edge view of our plane, and we'll see then where that plane, or the angle between that plane and the horizontal plane, being the XY line. So a strike line is a true length line because it's horizontal. So I'm going to use sliding set squares here. So sliding set squares. Out here, I'll set up my XY line or X1 line. Project out all these points. My canopy. Right, so here's my X1, Y1. Okay, I'm projecting from plan, so I'm creating an elevation. So it's an auxiliary elevation. Therefore, my heights are going to be the same between those two elevations. So height here of the canopy for R. Height for the canopy P. And the height at Q. Right, so that's an edge view of that canopy. Okay, and I want to find the angle between it and the horizontal plane. That's my dip angle. So, get another color here. Orange. Okay, and that is the dip angle. Okay, so I can measure that. I've got that at 27 or 8. Okay, so that's my dip angle. I've got that at 27 degrees. Okay, so that is geological geometry question for 2023 completed.